Hello, today we're going to cover Business Calculus 1.1. In any math class, the first chapter is always a little bit scattered because we're gathering up some pieces of hopefully review to put together into a bigger picture for the rest of the class. So we start with the kind of a refresher on some graphing and some function notation and everything. So remember that when we're dealing with the coordinate plane graph, we have an ordered pair xy, where the first number represents the x value, which is the distance left or right. And then the second number represents the y value, which is the distance up and down. This breaks our graph into 4 quadrants, and we label them in counterclockwise order. So just remember C for quadrant, which is funny because quadrant starts with Q, but it's just some silly thing to remember. So then we go 1, 2, 3, 4, labeling these quadrants, which just kind of gives us an idea of what we expect the values to be in each of these areas. So overall, we remember that if we wanted to plot a point with the x value and the y value, we would just go left, right, and then up, down to plot that point. And we could graph any function, is a smooth curved graph right here, by finding enough points that we could kind of get a feel for where the rest of them would be. So we don't have to plot every single one of these infinity points. We just need a few of them to spot where the general shape is. In this first question right here, they ask us to recognize which one of the three would follow this pattern right here. Now, it'd be tricky to try to plug this into our calculator because we only have the y equals button. We don't have an x equals button. So because of that, let's go back to basics and label a few points. So let's go find a few values, x and y, to see which one of these graphs is going to match up with this pattern right here. So we normally pick x's, but the way that this is set up, it would actually be a little bit easier to pick y's. So let's pick maybe -1, 0, and 1 for the y values, maybe 2, just to make sure we've really got a good picture. So if I were to replace the value of y with a -1, remember that we would need to use parentheses because the whole thing is what's going to be squared. So -1 in parentheses squared would be 1, 1 minus 1 would be 0. If I replace that letter y with a 0, 0 squared minus 1 would be -1. If I replace y with a 1, it's actually going to end up the same as this one right here, because 1 squared is also 1. That would put me at 0. And then if I replace y with the number 2, 2 squared is 4, 4 minus 1 is 3. Okay, now remember we're used to picking the x's and finding y's, so just be careful that you don't get these flip-flopped. These are 4 ordered pairs that should be on the correct graph. So let's go plot these points. 0, -1 would be 0 left and right, 1 down. So that would be here, here, and here. So I can see that I've already eliminated this last graph because he does not have the correct point. But from just this one point, I'm not sure which of these two graphs it is. So let's keep going. -1, 0 would be left 1, 0 up and down. So we're actually we're still confused by these two. They both have both points. Let's keep going. 0, 1. So that again is 0 left and right, 1 up. So now I can see that it's actually the second graph. Let's go ahead and just double check, I guess quadruple check with the last point. 3, 2, 3 to the right, 2 up, and sure enough, there he is. So you'll see that they tried to trick us with the same shape on this one and the wrong shape on this one, but a few of the right points. So just be careful that you're testing enough values to be super sure. So we see that this one actually would not be considered a function. It would not pass that vertical line test, which is why it was a little bit weird when we were plotting it out and why it was a little weird that we couldn't plug it into the calculator. Technically, if we did want to plug it into the calculator, it would have had to do 2 separate lines of y equals. I would have needed the plus square root and the minus square root to get this full picture on the calculator. So that's why we mostly deal with functions in this class, kind of the non-weird ones. So let's see a more normal looking one like this and see if we can plot it all by ourselves without a multiple choice option. So let's do that same thing and pick a few ordered pairs. Now I know we have the calculator, but let's go back to basics just to make sure we understand why. So this time I'm going to pick x's because it's in that more normal form. Let's do the same 0, -1, 0, 1, 2, and replace the x with each of these numbers. Again, be careful that in that first one I'm squaring the whole thing, -1 in the c squared is 1, the same because 1 squared is also 1, and then 2 squared is 4. 4 minus 2 is 2. So let's 0, comma, negative 0 is the same because 1 squared is also 1, and then 2 is 2. Now those zeros always get me, so just be extra careful on those. 0 in the first slot means I don't move left and right, I only go down. 1, comma, negative 1, and 2, comma, 2. So if you weren't absolutely sure, you could grab a few more points, and you should end up with some dots right in here. Okay, so you can kind of see it's going to be the shape of that parabola. Now, if it's your first time graphing on XYZ, you will need to be careful to put the vertex of the parabola first. So when you're selecting dots on XYZ, you'll need to put this one in first to get it to do the right thing. And then you could pick any one of these other dots. Now, doing it this way by selecting a few points and plugging them in, it took very little work. You should be able to run these numbers in your head without much difficulty, as opposed to trying to put it in the calculator and looking at those tiny little notches and maybe miscounting or looking at something wrong. So I would recommend doing it this way with the numbers, and then you can spot that vertex. You can see a few key points, which is what you're going to have to use to click on XYZ. You'll have to click at least 2 points. So always put the vertex first. And when you move away to click your second dot, it should form a parabola for you as long as you selected the parabola tool. Now we'll also notice, if you remember from your transformation rules, that it was the shape of a standard parabola that got shifted down to. So we see our regular U-shaped parabola, instead of coming right here at the origin, it started down to right here. Then everyone's favorite word problems. If you've had me before, hopefully you remember the first step to any word problem is don't freak out. You got this. In fact, this one might look familiar. He was actually in college algebra. This was a good one because we saw God's natural order in the shape of this oil spill, kind of a sad situation. And if you remember, I had you kind of spread this out because it almost makes it look like it flattens out there, but it is still spreading. So just to kind of make it look a little more spread outy, let's do that. Okay, so it's following this pattern where y equals the square root of x. So if they gave us that the plume was 49 meters down the river, and it asked us to find how wide it was, how far across the river, that value then would be the x. The x is the distance downriver. So I could just replace that value of x with the number they gave us, 49. And of course, the square root of 49 is 7. So it would be 7 meters across the river. Now this one is sneaky because it instead gives us the distance across, but it gives us the distance across in a sneaky way. It says, how far down the river would it reach halfway across? Well, now I need to know about the river. Up here in the story, it told me the river was 100 meters wide total. So that means halfway across would be a 50. Now 50 is the across, not the downriver. That means 50 is the value of y. So if I replace the letter y with the value of 50, if I needed to solve this for x, I would need to square both sides. And then of course 50 squared is 2,500. So you would have to go 2,500 meters downriver to get 50 meters across. And that should make sense because 49 meters down the river, pretty good ways, only spread out to 7. So you'd have to go a really long ways downriver to get halfway, 50 meters across. So it should all make sense. It should all go together. Just kind of double check that pattern as you go. So we mentioned that that first example was not a function because it didn't pass that vertical line test where any value of x should only have one value of y. So a pattern like this would not be a function. Now, if I wanted to specify the domain and range of a function or even a non-function, I remember that the domain is the x values and the range is the y. So just like alphabetically x comes before y, D comes before R, so kind of use that to help yourself remember. Now, if I had this non-function right here, I know he is not a function, but if I wanted to label his domain, the x values, I could see that it stops right here. There are no x values on this curve that are lower than 1. There's no x values over here. So starting at 1, but I do go up and up and up for the rest of forever. So I go to infinity. That would represent the x values. Now the 1 itself is included. If it looks like it hits the 1, it does hit the 1. It's not going to get close to him but then not touch it. There's no weird math that does that. But over here where he goes forever, that's infinity. We can never actually equal infinity unless we're Chuck Norris. So we have to use the round parentheses on infinity because you can't equal infinity. So that would be our domain. Now the range is the up and down, and we can see it's slowly spreading out to the right, going down, and slowly spreading out to the right, going up. So that means if you went out far enough, you could get down as far as you wanted, and you could get up as far as you wanted. There is no limitations on the up-down. It keeps spreading and spreading. Now, if I had just a single list of dots like this right here, then I would have specific x values. So this right here, if I wanted to list the domain, I would have specific dots, so nothing in between, but I would just have the numbers 5, 6, 5 again, and 2. Now I wouldn't list the 5 twice because I've already listed all of the specific x values. Now again, it's not from 2 to 6 because I couldn't actually hit 2.5. It was only these 4 specific dots. The range, same story, would just be those y values. So I've got the 9, the 7, the 2, and the 6. Now, if I wanted to know if he was a function, it's that same idea, the vertical line test. Right here, when I had these 2 dots, the 5, 9, and the 5, 2, would have gone 5 over and 9 up, 5 over and 2 up. So we could see that those 2 dots would have lined up vertically. They had the same x value, but different y values. So this one actually, right here, would actually not be a function, because we had those repeating x's. The other ones would be fine, be somewhere around in there, but those 2, the matching 5s, made us break the rule and not be a function. Let's try it again for these dots down here. So the domains are going to be the x values, 1, 5, oh, there's another repeat, and 4. So right here, I already know it's not going to be a function because that x value repeated. The range would be the y values, 1, 2, 4, and 6. And technically, I like to put them in alphabetical order, but on X, Y, Z, it doesn't count, 4 against you. So that's all you really need, just to list out those numbers. Again, it is not a function because of these repeating X values. They would have lined up vertically. This one right here, we've got a function. It is a function, because I could draw any vertical line I wanted and it would never hit this line more than once. Okay, now they happen to put dots on here, but don't be distracted by them. They are just kind of just pointing out some distinct dots. But we're looking overall at this blue line that continues on and on forever. So this blue line is a function. He passes the vertical line test. He wouldn't pass the horizontal line test, but that's something different. We'll talk about that in another lesson. So he is a function. If I wanted to list out the domain and the range, it's going to sound a lot like this one we did back here, but a little bit flip-flopped, because this time it's going to spread out left and right forever and ever. So if you went up high enough, you would reach some value to the left or to the right. It never stops. It never gets so steep that it's not spreading out anymore. So the domain would be all reals, from negative infinity to infinity. Again, we use those round parentheses because you can never equal infinity. And remember with the interval notation that it's always minimum, comma, maximum. So you do have to put it in this order or it would be counted wrong. So it'd be like saying, meet me from 5 o'clock to 2 o'clock. That'd be weird. You always start with a lower number. If you said you wanted to meet between 2 and 5, that's how you would say it. Okay, the range, just like this one, the domain was limited. This one, our range, our up and down, is limited. The very lowest value that it hits, which is right here at -1. I do use a square bracket because it did hit the -1. It just didn't get any below the -1. And again, don't be distracted by these dots. They were just trying to confuse you. Don't fall for their tricks. This one over here, instead of being our normal function that continues on like these two, it stopped. They stopped it at these dots. So whatever real life scenario might have made that happen, they were limited, it cut it off right here. So our domain would be specifically the x values from -2 up to +2. Since they used closed dots, I would use square brackets. did hit those dots. If they had been open dots, that would be a round parenthesis because they would have been saying it approached the 2 but didn't actually equal it. The range, be careful. Don't get hung up on the dots, the endpoints. It's all about the extremes. The most extreme left was here. The most extreme right was here. But the most extreme down is here. And the most extreme up is here. So the farthest down, the lowest y value is down here at -2. Again, if it looks like it hits there, it does. And then the most extreme up, the highest it reached was right here at the y value of 6. So think of these extremes right here, especially in a case like this where it stops, as basically the limits. You could box it in by going from -2 to 6, from -2 to +2, and then you could contain this whole function. You could draw a box around it, and it would stay inside of this box. Now this one right here would be a function. He doesn't pass the horizontal line test, but that's something different. He passes the vertical line test. Now, if we did have something like this, even though it passed the vertical line test here and there, this would not be a function because if it ever crossed more than once anywhere in the whole entire function, it would not be a function. So just be careful. Now, last we've got this guy here. He's a little bit sneaky, but it's the same rules. So on this one, it's just this straight little piece of a horizontal line. So my domain is from -1 to 2. Again, it has those distinct dots. It did stop. The range is what's sneaky. The range is the up and down, but in this case, it never moved up or down from its original point. It always had the same exact y value of 0. Now, just like these back here where it was distinct points, not a range, I put it in curly brackets. Don't worry about it too much. X, Y, Z is going to take care of that part for you, but just explain why it was different. It's not from 0 to something. It's just 0 specifically. And this one, sure enough, would be a function. You would never cross the vertical line more than once. Okay. All right. So just again, a refresher on graphing and function notation. Remember that f of x is basically the same as the letter y. It's the output for any given input x. So if I had the output equals -1/2 times the input plus 3, and I wanted to find where the output was equal to the input, where f of x equals x, well, I'm just going to literally do that. F of x equals this pattern right here, and I'm going to see where that pattern right there is equal to the input x. F of x equals x. So I have a lot of people miss this problem, and it always makes me sad because it's secretly easy. You just have to think what it's asking. F of x, this, equals x, just like that. Now it's just a little baby algebra problem. You've got this. There's a fraction, but don't be scared. You got your calculator. You're going to get those x's together, because remember, I can't solve for x if he's in more than one place. Cancels them here on the left. Remember that this is 1 whole x, so 1 whole plus another half would be 1.5 or 3 halves. If you're not great with fractions, don't worry about it. You could punch in your calculator 1 plus 1/2, math enter, and it would give you this 3 halves. You could even have left it as the decimal. Either way, if you left it at 1.5x, it will work out exactly the same. I'm going to write it as the fraction, because fractions are always more exact. If it was ever a repeating decimal, you would have a rounding error, but the fractions are always going to work. They're always exact. So in this last step, when I wanted to solve for x, I have 3 halves times x. I undo times with the divide, but I have to be careful to use my parentheses around the fraction, or it will mess up. So when I'm typing this in the calculator, I'd say 3 divided by parentheses 3 halves, close parentheses. If you do it that way, it should give you the final answer of 2. Now, what does this mean? Besides doing a weird little algebra problem, this is saying that if I found f of 2 by taking -1/2 times 2 plus 3, well, -1/2 times 2 would be -1. -1 plus 3 is 2. f of 2 is 2. And that's the only place on this whole entire graph that that would happen, where the x and the y value would match. So let's see if we can graph this function right here. If you remember your y equals mx plus b, this one would have an intercept of 3, the constant 3, and the slope of negative 1/2, which means from that intercept we would fall 1 and run 2. Because remember, a negative slope should have a downward tilt. If you sign your name on the line, you're going down, which means you could either go up and left or down and right, but not both, because if you go down and left, that's a double negative that makes a positive slope. So you should have this negative slope. I'm going to put a few more dots on here just so I can try to graph a straight line. I am not good at graphing straight lines on here. Wish me luck. All right, not too bad. We'll go with that. All right. So what it's saying is that if you found some dots on here, like this dot at -2, 4, -2 and 4 aren't the same. -4 and 5, -4 and 5 aren't the same. 6 and 0, 6 and 0 aren't the same. This is the only dot on the whole entire graph where the x value and the y value are exactly the same number. F of 2 is 2. So if I wanted to kind of prove that, here's the line graphed f of x. And then it said on the same graph, let's graph the line x equals 2. Remember that that is the vertical line where all of the x values are 2. So you can have any y value you want, but all of the x values are 2. So no matter which 2 dots I pick, my x's were 2. Okay. And then last, on the same graph, it wants me to do one more thing. It wants me to plot the point of 2, f of 2. And that's that one we were just talking about. 2 f of 2 ended up being 2, 2. Okay, so be careful on this one on XYZ. Sometimes people get a little confused because it's not super clear, but they want you on the same graph to graph 2 lines and 1 dot. So you'll use your line tool twice, and then there's a dot tool that you'll select to put this one single dot right here. Okay, and that's our quick refresher on section 1. Just let me know if you have any questions.